Numericals relating meter bridge. Find the value of unknown resistance X and the current drawn by the circuit from the cell if no current flows through the galvanometer. Circuit is also given in the question. So in the circuit itself it is given, in the left gap unknown resistance X is connected and in the right gap 2 ohm is connected and balance length is 60 centimeter because 60 centimeter is the balance length because at that time galvanometer shows null deflection, zero deflection. So directly we can write the formula. Wheatstone's, this is meter bridge is an application of Wheatstone's bridge that we know. So we can write X divided by 60 equal to 2 divided by 40. Right. So we can write from the meter bridge arrangement or from the Wheatstone's bridge balance condition, we can write X by 60 equal to 2 divided by 40. Okay, so X is equal to, simplifying, 2 into 60 divided by 40. So it is equal to 3. Simplifying, you will get. Okay, so actually 60 ohm means along with that length we can multiply resistance per unit length also. Here also 40 centimeter it is multiplied by resistance per unit length. So in the derivation we already discussed. So that resistance per unit length can be cancelled. So directly we can write X by 60 is equal to 2 by 40. So what is that unknown resistance? X is equal to 3 ohm. In meter bridge the null point is found to be 60 centimeter from A. If now a resistance of 5 ohm is connected in series with S, the null point occurs at 50 centimeter from A. Determine the values of R and S. So in the question, R and S are given, the figure is also given. So if R and S are connected like this, what is the balance length? 60 centimeter from A. So this length is 60 centimeter and remaining will be 40 centimeter. Okay, so how will you write the formula? We can write R divided by S. Okay, R by S equal to 60 by 40 or R by 60 equal to S divided by 40. Like that we can write. So R by S is equal to 60 by 40 from Wheatstone's bridge balanced condition. Or we can write R by S is equal to 3 divided by 2, or we can write R is equal to 3S divided by 2. Okay children. Now if 5 ohm is connected in series with S, so if 5 ohm is connected in series, equivalent resistance become S plus 5, isn't it? If R1 and R2 are connected in series, equivalent is R1 plus R2. Similarly, if 5 ohm is connected in series with S, equivalent resistance becomes S plus 5. So now we can write the second as R by S plus 5 is equal to, what is the balancing length then? It becomes 50. So this remains 50 means what is this one? This is also 50. So 50 by 50. Isn't it? So we can write R divided by S plus 5 equal to 1 or R equal to S plus 5. Then substitute the value of R from this equation. So we can write 3S divided by 2 equal to S plus 5 or 3S is equal to 2S plus 10. Isn't it? So S is equal to 10 ohm. So the value of the resistance S is equal to 10 ohm, and substitute in this equation we can obtain the value of R. So R equal to 3S by 2. So since S is equal to 10, R equal to 3 into 10 divided by 2, that is equal to 15 ohm. So these are the two resistance, value of the resistance 10 ohm and 15 ohm. Third question, in a meter bridge the null point is found to be 40 centimeter from A. If a resistance of 12 ohm is connected in parallel with S, the null point is occurs at 50 centimeter from A. Determine the values of R and S. Again the same meter bridge figure is given. R is connected in the left gap and S is connected in the right gap. So what is the balance length given? It is 40 centimeter from A. So now in the first case we can write R by S is equal to 40 by 60, isn't it? So if R is connected here, S is connected here, in the question it is given the balance length is 40 centimeter from A. So this one is 40, so remaining is 60. So now R by S is equal to 2 divided by 3 or R is equal to 2s divided by 3. That is the equation. Now second case, if 12 ohm is connected in parallel with S, if 12 ohm is connected in parallel with S, what is the balance length? 50 centimeter from A. So now we can write, if 20 ohm, not 20 ohm, 12 ohm, 12 ohm is in parallel with A, parallel with S. If 12 ohm is connected in parallel with S, what is the balancing length? 50 centimeter, that we know. So, if 12 ohm is connected in parallel ways, what is the equivalent resistance? 1 by Rp equal to 1 by S plus 1 by 12. Okay, 1 by Rp becomes 1 by S plus 1 by 12 is equal to, we can take the LCM, 12S, here 12 plus S, that is 1 by Rp. So, what will be the value of Rp? Rp becomes, here Rp can be written as equivalent resistance is 12S divided by 12 plus S. Right. So, this equivalent resistance is connected here in place of S. So, now the formula become R divided by here Rp. The new equivalent resistance is Rp equal to 50 by 50. Balance length becomes 50, remaining is also 50. So, R by Rp equal to, instead of S, here the new resistance is Rp, because S and 12 are connected in parallel. So, R by Rp equal to 50 by 50, or R divided by Rp. What is the value of Rp? 12S divided by 12 plus S is equal to 50 by 51, or we can write R equal to 12S divided by 12 plus S, isn't it? Then we can substitute R from this one. R is equal to 2S by 3. So, R is equal to 2S by 3 equal to 12S divided by 12 plus S. We can cancel this S, or 2 into 12 plus S is equal to 3 into 12. Okay, 2 cross multiplying, 2 into 12 plus S is equal to 3 into 12. So, that is 24 plus 2S is equal to 36, or 2S is equal to 36 minus 24, which is equal to 12, or S is equal to 12 by 2 is equal to 6 ohm. So, S is equal to 6 ohm. If you know the value of S, substitute in any one equation and we can write the formula for R. So, R equals 3S by 2S by 3, sorry, R equal to 2S by 3 is equal to 2 into 6 divided by 3 is equal to 4. So, using this method we can easily find the value of R and S. The given figure shows the experimental setup of a meter bridge. The null point is found to be 60 centimeter from A with X and Y in position. When a resistance of 15 ohm is in series with Y, the null point occurs to shift by 10 centimeter towards A. Find the position of the null point if a 30 ohm were connected in parallel with Y. So, if X is here and Y is here, what is the balance length? Given balance length is 60 centimeter from A. So, first we can write that formula. If X is connected in the left gap and Y is connected in the right gap, we can write X by Y equal to 60 by 40. Okay, so X by Y is equal to 3 by 2. That we can write from the given figure, right. When a resistance of 15 ohm is in series with Y, null point occurs to shift by 10 centimeter towards A. So, initially it is 60, now it is shifted by 10 centimeter towards A, means what is the balance length? Balance length becomes 50 centimeter, shifts by 10 centimeter towards A, that means the balance length becomes 50 centimeter, right. Now, if 15 ohm is connected, if 15 ohm is connected in series with Y, equivalent resistance become, we can write the equivalent resistance as equivalent resistance is equal to Y plus 15, isn't it? Y plus 15. Now we can write the formula as equation as x divided by y. Instead of y we can write y plus 15. Y plus 15, balance length shift by 10 centimeter means it becomes 50 by 50. So x by y plus 15 is equal to 1, or we can write x is equal to y plus 15. Now from this equation x can be written as 3y by 2, no? So here we can write x is equal to 3y divided by 2. Substituting, we can write x is equal to 3y by 2 is equal to y plus 15, or we can write 3y is equal to 2y plus 30, or y is equal to 30O. If y is equal to 13O, we can write x as x is equal to y plus 15, isn't it? Is equal to 30 plus 15. So x is equal to 45O. We got the values of x and y as 45 ohm and 30 ohm. Now next part is find the position of the null point if 30 ohm is connected parallel to y. So if 30 ohm is connected in parallel to y, the equivalent resistance can be written as, if 30 ohm is in parallel with y, we can write the equivalent resistance as 1 by equivalent resistance. Here parallel, no? So 1 by equivalent resistance is 1 by 30 plus 1 by y. So LCM can be written as 30y, so it becomes y plus 30, or 1 by r. And we know the value of y. What is the value of y? 30 ohm, isn't it? So 30 plus 30 divided by 30 into 30. That is 1 by R equivalent. So R equivalent is equal to, what is R equivalent? R equivalent is equal to 15 ohm. Right. Equivalent resistance is 15 ohm. Now we have to find out the null point or balancing length. So now we can write x divided by, instead of y we can write this R equivalent, because 30 ohm is connected in parallel to y, isn't it? So x divided by R equivalent is equal to, we had to find out the balance length. So we can write L divided by 100 minus L. Substituting, x is equal to 45, R equivalent is equal to 15 is equal to L divided by 100 minus L. Now it is 3 is equal to L divided by 100 minus L. So cross multiplying, 300 minus 3L is equal to L, or 300 is equal to 4L, or L is equal to 300 divided by 4. 300 by 4 is 75 centimeter. So balancing length, if 30 ohm is connected in parallel to y, the new balancing length becomes 75 centimeter. Now we can do some questions relating potentiometer. The variation of potential difference with length in case of two potentiometers A and B are given. Which of the two is preferred to find EMF of a cell? Give reason. So graph is given, length along the x-axis and potential difference along the y-axis. So here for two potentiometers A and B. Right. We can redraw the graph like this, and keeping voltage constant we can draw a perpendicular. Here this is the length corresponding to A and this is the length corresponding to B. Okay. Now we have potential gradient. We know potential gradient of a potentiometer is, potential gradient is equal to potential drop by length, potential difference divided by length. Okay, so potential gradient corresponding to A can be written as potential gradient of A can be written as potential difference divided by length, LA. Similarly, potential gradient corresponding to B can be written as V divided by LB. So from the graph itself it is given length, which length is greater? LB is greater, isn't it? So LB is greater than LA. And since LB is greater than LA, potential gradient corresponding to B is less than potential gradient of A. Potential gradient corresponding to A. So, B potentiometer has less potential gradient than A, that of A. Okay. So, as potential gradient is less, sensitivity will be more. Smaller the potential gradient, greater will be the sensitivity. So, since B has lesser potential gradient, this B is considered to be more sensitive. So, which is more preferred to find the EMF means B is more preferred. So, since potential gradient is less, B is more sensitive and hence B is preferred. Right, as potential gradient is less, sensitivity will be more and hence B is preferred for finding the EMF of the cell. A potentiometer wire of length 1 meter is connected to a driver cell of EMF 3 volt. When a cell of 1.5 volt EMF is used in the secondary circuit, the balance point is found to be 60 centimeter. On replacing this cell and using a cell of unknown EMF, balance point shifts to 80 centimeter. Calculate the unknown EMF of the cell. Explain whether the circuit works if the driver cell is replaced with a cell of EMF 1 volt. Does high resistance R used in the secondary circuit affect the balance point? Justify. So, figure is given in the question. This is a board question. Okay. Now, so this potentiometer, the given figure is similar to the potentiometer already have studied in the theory portion. So, this potentiometer, this is a 6 meter potentiometer. This is also some 6 meter or 10 meter potentiometer. It is arranged like this, a single wire. So, this AB represents a potentiometer. Here 3 volt represents the primary circuit. This is the primary circuit, isn't it? Across A and B, primary circuit is connected. So, this is the primary circuit where a single cell is connected. This represents a secondary circuit where a cell of 1.5 volt galvanometer and a resistance is connected. Okay, so this actually represents the primary and this represents the secondary. So, this is same as the original potentiometer circuit diagram. Okay, children. Now, here this is called a driver cell. The cell which is connected in the primary connection is called a driver cell. So, it is this cell provides current for the working of the potentiometer. Okay, so therefore it is called a driver cell. Now, driver cell of voltage 3 volt. When a cell of 1.5 volt is used in the secondary, balance point is 60. So, if 1.5 volt is used in the secondary circuit, what is its balancing length? 60 centimeter. Now, 1.5 volt is replaced by another cell. What is the balancing length? 80 centimeter. So, first question is we have to find out the unknown EMF of the cell. So, we have unknown EMF. We have the formula for comparing the EMF of the two cells. So, first question formula is E1 by E2. Ratio of the EMF equal to ratio of the balancing length, you know. That is the first application of potentiometer. So, E1 is, we can write E1 is 1.5 volt. E2 is unknown, divided by what is the balancing length corresponding to E1, that is 60, divided by what is the balancing length corresponding to E2, that is equal to 80. Okay. So, E2 is equal to unknown balancing length E2 is equal to 80 into 1.5 divided by 60. So, after simplification you will get it as 2 volt. So, unknown balancing length is equal to 2 volt. Now, second one. Explain whether the circuit works if driver cell is replaced by a cell of EMF 1 volt. So, the driver cell connected in the primary. If its voltage is less than or its voltage is 1 volt, does the circuit works? That is a question. So, the driver cell voltage should always be greater than the voltage or EMF connected in the secondary, because this driver cell provides current for the actual working of the potentiometer, and hence its voltage should be greater than voltage or EMF connected in the secondary. So, if it is 1 volt, does it works? No, because the EMF connected in the secondary is 1.5 volt and 2 volt. Okay, so if it is 1 volt, it does not works. If it is 3 volt or more, then only it works. So the question is whether the circuit works if the driver cell is replaced with a cell of 1 volt, the circuit does not work. That is the answer. The circuit does not work because the voltage of driver cell should be greater. Voltage of driver cell should be greater than EMF or voltages of the cell connected in connected in secondary circuit. Okay, so driver cell voltage should be always be greater than voltages of the cell connected in the secondary region. And the third part is, does the high resistance R used in the secondary circuit affect the balance point? So R is the resistance connected here in the secondary region. At the balance point, does the value of the resistance affect any reading, affect the reading? That's the question. Does the high resistance R used in the secondary circuit affect the balance point? Because a balance point means, is there any current flowing through the galvanometer? No, no current is flowing through the galvanometer. So whatever be the value of resistance, it does not affect. Because at the balance point, the current through the galvanometer and this region is equal to 0. No current is flowing. No current is flowing through the galvanometer means no current is flowing through the resistance. So the value of resistance does not affect. So third answer, no. The value of balance point, the balance point is not affected, by the high resistance R. Because at balance point or at balance condition, no current flows through the galvanometer. No current flows through the galvanometer means no current flows through the resistance. Okay.